current section, and then last we'll land. All right, so it says for us to revisit the present-day Statue of Liberty. So if you're looking at the present-day Statue of Liberty, that's on the board. We know at this point we already explored the phenomenal question, how can we improve our model of air? Now I want you guys to consider how you might apply your updated model to the entire Statue of Liberty system. So we talked about air, and we know at this point that air is what? Air is a gas. Right? So it says that we're going to apply our knowledge now to our updated model of the entire Statue of Liberty system. So it says, we know that gas particles must be colliding with the flag due to our investigation. Why do you think the arrows are important? What is the arrow showing us?
Which way is which
Well, hold on,
direction?
hold on. Because I'm only hearing from this side and I need to pull from this side. 19. Who's number 19?
Me?
Go ahead, Zane.
You need the arrows on the particles to see which way the particles going. Like when you threw the marble yesterday, it was colliding with the discs, but you couldn't see. You could see like which way it was going because the marble was big. It wasn't like a gas particle.
Yes.
What we need to do and help us work better as a group. So a reporter, materials manager, timekeeper, and then participant. So take a second. I'm going to put the timer on for 3 minutes. 1 in 3 minutes, where you have to have decided what you're going to do and to have read the back.
Oh, 152, and now keep going. Take this down and go again.
Wait, make sure you know where it is.
I know, there's a little Okay.
Okay, so we're going to do this just like we did. That's right.
So they didn't flip it. They can't flip it.
Questions do you already have? Think about your own personal experience with vaccines. Think about what you've ever been told about vaccines. Think about what they just said and what's going on here in Rockland. They're reading the questions, and we're going to group them and go through them to see what's important.
Mal, you can see right there?
What is called again?
Measles?
Measles.
Is that a word you don't know how to say?
Yeah, I got a question. It says measles in LA.
Louisiana.
Oh.
How deadly is the measles?
Okay, so how deadly is it?
How long does the measles, how you say it?
Measles.
Measles last?
Why can't the Jewish take the medicine, I guess they say?
Okay, so take the vaccines.
Why they're not allowed in public places?
So if you're not vaccinated, why are you not allowed in public places? That's a great question.
How does the measles spread?
How does it spread?
What are the symptoms?
What are the different symptoms? And look, guys, I like that Kevin's doing it on the table. He's kind of organizing them and grouping them. What else we got, y'all?
How many cases were reported in Rockland County?
Okay. You're going to research and go through vaccines, the pros of them, why we do them. There was, about 20 years ago, a study, a single study that was done that said something about vaccines. It said something negative about vaccines. So I want you to research that, what that experiment was and what he did. Remember this morning with our governor, we reviewed experimental design. I want you to look at his experimental design and see how he set it up to see if it was a good experiment. The other thing that I have linked here, which I want you to take your own time as a group and look at to see if you notice the trends in the data. These are some this is vaccine information from the past several years from the CDC. The one I'm going to point out, because it's what we're talking about now, is measles. Guys, look at these bar graph. Look at this bar graph.
Let's see.
In theory, herd immunity means not everyone in a community needs to be immune to prevent spread of disease. The higher proportion of individuals in a population are immune, the majority will protect a few.
That's what I want you to think about as you write your questions. What is the virus' ultimate goal?
To reproduce and to infect everything, to try and take over the host.
That's the major thing because it has to reproduce.
How long does it take a virus to hijack a cell?
Depends how strong the virus is.
If it's strong enough, it'll hijack it faster than a weak virus. Can a hijacked cell return to its original state once infected by the virus? If so, can that one hijacked cell replicate enough to take on a human body?
That one cell can't return back to normal because it gets destroyed. And then another cell has to come and replace that cell.